Thank you. Hello everyone. Today I would like to present my work about the electronic and magnetic properties of Ne2MnGa alloy using two approach ab-initio calculation by KKR CPA package and Monte-Carlo simulation based on Metropolis algorithm. For this, we use this plan, which is organized as follows: four sections. First section is introduction. In section 2, we explain the compilation method, ab initio calculation, and Monte Carlo simulation. The results are presented in section 3. Section 4 concludes this work. Magnetic refrigeration is a cooling technology based on the magneto-caloric effect. This technique can be used to attain extremely low temperature, as well as the ranges used in common refrigerators. The technology chip memory is an alloy that remembers its original chip and that when deformed returns to its pair deformed chip when heated. This material is a lightweight, solid state alternative to conventional actuators such as hydraulic, pneumatic, and motor-based systems. Chip memory always have applications in robotics and automotive, aerospace, and biomedical industries. Our system can exhibit the two technology, so we will use the ab initio calculation and Monte Carlo simulation to investigate the electronic and magnetic properties of Ne2MnGa. So we use the AKKR package, which is used the method KKR CPA method that performs DFT calculation, is used to calculate the local density approximation. The Cohen-Sham equation and energy functional were evaluated consistently using the KKR CPA method with the valence electron configuration for the Ne, Mn, and Ga. Our system in E2 MnGa is among the family of wholesale compounds which crystallize in the L21 structure with the space group of FM3M 2025. Their lattice parameter is A equal B equal C equal 582 angstrom. This is represented as four interpenetrating face-centered cubic sublattices. The Ga and Mn atoms occupy the position 0, 0, 1 half, 1 half, 1 half. Although the Ne atoms get the set 1 quarter, 1 quarter, 1 quarter, and 3 quarters, 3 quarters, 3 quarters. This is mentioned in the figure. Alright, the code was performed by two approximation LDA with VWN other LDA is based on the parameterization given by MJW and GGA. We have used the highest cap points up to 600 for the calculation energy and magnetic moment, but for the density of state dose, the highest cap point up to 250. And the relativity effect has been considered in using the scalar revertizated approximation. So the next step is the Monte-Carlo simulation. We have used the Ising model, the Hamiltonian H of the Hölzer in E2 MNGA, alloy including the exchange interaction is given by this. And we have used the Metropolis algorithm with the probability. And we have used the cycle boundary condition on the lattice. Alright, it has been found that the energy total of the system in E2M in GA obtained by the approximation GGA was smaller than the LDA approximation. This means that GGA is optimal for our compound. So, from that result, the rest calculation will be treated by GGA approximation. We have introduced a new approach to determine the exchange interaction by the calculation of the total energy differential delta E between the disordered local moment and the ferromagnetic state based on the mean field approximation. Alright. So we obtained the value of the exchange interaction from the three equation and the table previous. So the next step we have calculated the total and local magnetic moment. The table gives the results from our simulation. It is noted that the total and local magnetic moment of NA2 MNGA is estimated better with GGA approximation in comparison to experimental data. As may be seen, the density of state does give an information. There is an overlap at the Fermi level, which means that our system has a metallic behavior. It is concluded that the orbitals 3D of nickel and 3D of magnesium and 4p of gallium Ga contribute the most in total density of state of in E2M in Ga, because these orbitals are not occupied, and the contribution of the orbital 4pGa is negligible. The band structure confirmed our compound in E2MEGA has a metallic behavior, which there is an overlap of bands at the leaf gamma is mentioned in the figure. So, the obtained magnetic moment has been used as input of Monte-Carlo simulation. The Monte-Carlo simulations is used to calculate the terminal magnetization, such as the given in the figure. The transition from ferromagnetic phase to the paramagnetic. One occurs the figure at the temperature at the Curie temperature. Tc is 500 K. We present the magnetic susceptibility as a function of the temperature. It is observed that the peak of the magnetic susceptibility and it is corresponding critical temperature. As conclusion, in this work we have investigation the electronic and the magnetic properties of Ne2 MnGa alloy using the two simulation approach, ab-initio calculation and Monte-Carlo simulation. We found that these properties show that the alloy are considered to be most promising candidates for various applications, including chip memory, magnetocaloric, and other phenotronic applications. Thank you very much for your attention.